Welcome to the Daily Scholar. Today we focus our mathematical analysis on a specific type of geometric transformation, the rotation of points on a coordinate plane. Understanding how coordinates map during these operations is foundational for advanced geometry and spatial reasoning. Let us begin by the table of contents. The first one we'll be going over is the definition. The second one we'll be going over is the three quick rules that I invented. And the third one, we'll be going over a sample question. Okay, first, what does it even mean to rotate a point? A rotation is a rigid motion that turns a figure around a fixed reference point designated as the center of rotation. In high school coordinate geometry, this center is standardly defined as the origin or 0, 0. Every rotation is dictated by a specific degree angle. By mathematical convention, the direction of rotation is always counterclockwise unless explicitly stated otherwise. Because a rotation is a rigid motion, the distance from the center of rotation to any point remains perfectly constant, thereby preserving the exact dimensions of the figure. Next, to rotate a point x, y around about the origin, we apply precise algebraic mapping rules depending on the angle of rotation. We define these three primary operations as follows. First one, for 90 degrees counterclockwise rotation, we have x, y is negative y, x. The coordinate swap positions and the new x coordinate is negated. Second one, for a 180 degrees counterclockwise rotation, x, y is negative x, negative y. The coordinates remain in their respective positions, but both signs are negated. For a 270 degrees counterclockwise rotation, we have x, y is y equals negative x. The coordinate swap positions and the new y coordinate is negated. Let us apply these precise criteria to a sample problem. But first, before we go over the question, I want to talk about the quick rules for rotations about the origin. So I would encourage you guys, to take a picture or, write it down and pause the video and understand this, because this is really, really going to help us in our sample problem or in your future geometric problems. Alright, let's go over a sample problem. Let's apply these precise criteria to a sample problem. Point P has the coordinates 2, negative 5. Determine the coordinates of the image point P prime after a 180 degrees counterclockwise rotation about the origin. I would encourage you guys to pause the video and try it out yourself. Alright, let's go over the answer. So to solve this systematically, we execute a three-step mathematical analysis. So step 1, we identify the corresponding algebraic rule. So for 180 degrees rotation about the origin, the mapping rule is x, y is negative x, negative y. And notice I gave you a hint in the problem itself. Here, right here, the rule, I gave you guys the rule. And if some of you noticed it, well, congratulations, you're more likely to get the problem correct. Okay, guys, remember this. In mathematics, the negative sign in front of a variable means take the opposite of. It does not automatically mean the final number will be negative. Step 2, let's define the initial input values. So for our given coordinate pair, point P 2, negative 5, we identify that x is equal to 2 and y is equal to negative 5. Now that since we know the values, now we substitute x equals 2 into the rule for the first coordinate. So we write negative x equals negative 2 in parentheses, which becomes negative 2. So we substitute y equals -5 into the rule for the second coordinate. So it becomes -y equals negative and -5 in parentheses. Since negative times a negative is a positive, we get -y equals 5. By mapping these transformed coordinates back into our ordered pair, we observe the final geometric transition. 2, -5 is -2, 5. The coordinates of the rotated point P prime are -2 and 5. This completes our analysis of geometric rotations. Apply these precise algebraic and geometric steps to maintain mathematical accuracy in your transformations. Thank you for watching. Please subscribe to the Daily Scholar for more academic tutorials.